Hello, this is Adolf. Welcome to the video lecture series on the course of Design of Steel Structure. This is the lecture number 8 on unit number 6, that is beams. In this video lecture, we are going to see about the plate girders. Under the plate girders, we are going to see the introduction to the plate girders, what are the types of sections used, and what are the components of plate girders, and what are the functions of each component of the plate girders. So these are the topics we are going to cover in this video. So let's start our video lecture on the topic Introduction to Plate Girders. Plate girders are a build-up sections. So if you are going to connect it with a welded connection, then both the web and the flanges will have plate sections. So if you are going to connect your plate girder with a riveted connection, then your web will have plate section and your flanges will have angle section with or without cover plate. So welded connection, both web and flanges will have plate section, whereas in the riveted connection, web will have plate connection and flanges will have angle sections with or without cover plate. These plate girders are flexural members. Flexural members means the members which are subjected to bending. So the members which are subjected to bending, we will call it as a flexural members. The bending resistance of the plate girders can be increased by increasing the distance between the flanges. So if you increase the distance between the top and the bottom flanges, then your bending resistance can be increased. And if you increase the web area, this will also increase the shear resistance. So for bending resistance, we have to increase the distance between the flanges, and if you want to increase the shear resistance, you have to increase the web area. And this plate girders are primarily provided in the bridges. You will see in the bridges we will have the plate girders. Mostly these plate girders will be used in the bridges. Plate girders are economical when it's very large. So if you are going to erect a section for a very large sections, if you are going to fabricate for that sections, plate girders are very economical. Say beyond 20 meters. So if you are going to do a section beyond 20 meters, then your plate girders are very economical. These plate girders are also very common in building where heavy concentration load from upper story columns act on a long span. So if your span is very long, you have a beam of a very long span and a heavy concentrating load is applied on that beam, we will use the plate girders. Mostly in the building we will use in that way. So for any other examples like a dining hall floor beam of a restaurant, if you take a dining hall or an auditorium, the beam, it requires a clear span all through it. Intermediate, we won't use any beam. So that time we will go for the plate girders. So next topic is what are the types of sections used as plate girders. So there are 4 types: A, B, C, D. So A and B we will use it in the riveted connection, and C and D we will use it in the welded connections. So see where we will use these type of sections. So when the load and span are large, the plate girder sections either with welded connections or riveted connection or welded connection may be used. So if your load is large and the span is also large, we can use A, B or C. We can use, may be provided. The number of flange plates may be increased depending upon the moment to be resisted. So if your moment of resistance, that bending moment is high, we have to increase the flange plate. So that's the point. It says the number of flange plates may be increased depending upon the moment to be resisted. And if the depth is limited, so if the depth of the beam is limited and the load is too large, and a box welded plate girder, figure D. So in that figure D, we can provide. So first three types we will use when the loads and the span are large. We will use first three types. But if the depth is limited and the loads are too large, we will go for a box welded plate girder. That is figure number 4. A box girder with riveted connection can also be made. It is costly as compared to the welded one. So we can, instead of welded, we can go for the box riveted plate girder also, but the cost wise it will be very high when compared to the box welded plate girder. And box girders have the advantages of great resistance to lateral buckling and torsion. So which section will have the great resistance to lateral buckling and torsion is box girders will have the great resistance to lateral buckling and the torsion. Next is, what are the components of plate girders? So there are various components of a riveted plate girders that are shown in the diagram. The first one is web plate. So this is the web plate. This area is the web plate. Second one is flange angles. So this web plate and it is flange, it is connected. So we are using the flange angles. So this is the flange angles. Flange angles. Third one is bearing stiffness. So the bearing stiffness, here it is. These are the bearing stiffness. And the fourth one is vertical stiffness. Here this one is the vertical stiffness, and the fifth one is horizontal stiffness. So this and all horizontal stiffness. Next is web slicers. This portion is called web slicers, and last one is flange slicers. Last one is flange slicers or flange. This is the these are the components of the web plate. Let's see the function of each component of the plate girders. Let's start with the web plate. The major function of the web plate is the web of the plate girder resists the entire shear force. So the main function of the web of the plate girder is to resist the entire shear force. But sometimes due to the excess load, this web plate may buckle. So the web plate sometimes buckle due to the excess load. So to avoid this web buckling, we are providing the vertical and horizontal stiffness in the plate girders. So why we are providing the horizontal and vertical stiffness is to avoid the web buckling. So this web plate is to resist the entire shear force. So what is the average shear force that is acting on the web plate is calculated by tau VA calculated is equal to V is the maximum shear force on the girder divided by dW is depth of the web plate into TW is thickness of the web plate. This whole term should be less than or equal to tau VA. So tau VA is, now it is 0.4 Fy. Tau VA is equal to 0.4 Fy. So this is the function of the web plate. Second component is flange angle with or without cover plate. So flanges are essentially consist of flange angles. So this flange angles is used to connect the web plate with the flange. So it is designed for resisting the maximum bending moment over the beam. So web is to resist the maximum shear force and the flange is to design for resisting the maximum bending moment over the beam. So it increases the moment of inertia. It increases as moment of inertia increases. So that the resistance to resist the bending moment, it increases when the moment of inertia increases. To increase the moment of inertia, additional flange cover plates can be provided. So if you want to increase the moment of inertia of the member, we can provide the additional flange cover plate. So this is the function of the flange angle. Third component is bearing stiffness. So these bearing stiffness are provided at the point of concentration load and at supports. So this bearing stiffness will be provided at two places. One at the point of concentrated load acting on where it should acting. Second, at supports we will give the bearing stiffness. The end of the load bearing stiffness should be milled to fit tightly. So we have to mill the section to fit tightly. So and to provide a uniform bearing upon the loaded flange. So why we are milled to fit tightly means to provide a uniform bearing upon the loaded flange. So this is the function of the bearing stiffness. Next is vertical stiffness. Where the vertical stiffness are required is they should be provided when the length of the girder at distance not greater than 1.5 d1 and not less than 0.33 d1. That is one. Sorry. So not greater than. That means 1.5 d1 and it should be greater than 0.33 d1. In that place we will give the vertical stiffness. So well, what is the d1 is? D1 is the clear distance between the flange area when no horizontal stiffness are provided. From the flange area, a clear distance from the top flange to the bottom flange, that distance, clear distance where no horizontal stiffness are provided, we will calculate the distance d1 area. So if any when the horizontal stiffnesses are provided, so in that if the horizontal stiffnesses are provided, then the d1 is clear distance between horizontal stiffness and tension flange ignoring fillets. So if this is the horizontal filler. So if it is horizontal filler is given, then we have to consider the distance between the horizontal filler to the tension flange. We have to consider. So if no horizontal fitness are provided, D1 is the clear distance between the flange angles, that is top and bottom. If horizontal stiffness are provided, then the D1 distance is clear distance between horizontal stiffness and tension flange. The fifth component is horizontal stiffener. So this horizontal stiffener are extended between the vertical stiffness. See here, this is the horizontal stiffener. So horizontal stiffeners are extended between the vertical stiffness, but need not to be continuous over them. So it should not be continuous over them, but it is between the vertical stiffness we will provide. So this is one vertical stiffener, here one vertical stiffener. So between that we are providing the horizontal stiffness. A sixth component is web slices. So this is the web slices. So slices in the webs are provided when the span of the girder is more than the available size of the plate section. So when your span of the girder is more than the available size of the plate section, then we will use the web slices. These web slices may also require to facilitate the fabrication work. So it will help in the fabrication work to join the two members. So the slices in the web plates are designed to resist shear and moment at the sliced section. So this is the sliced section. So at that place it is designed to resist shear and the moment at this sliced section only. This is the function of the web slicers. The final component is flange slicers. As like as the web slicers, we will provide it in the flange also. The flanges should be sliced at the point of maximum bending moment. So, where we will provide the flange slices is at the point of the maximum bending moment we will provide the flange slices. The area of the slice plate should be 5% more than the area of the flange element sliced. So the area of the slice plate should be 5% more than the area of the flange element. And the center of the slice plate and the flange element slice should coincide as far as possible. So these are the functions of the flange slices and also the functions of the each component of plate girders. So in this video, we saw what about the plate girders, what is the introduction to it, what are the types of section we are using, what are the components of the plate girders, and what is the function of the each component of the plate girders. Thank you.